So we are now recording. So we're going to still be solving systems of equations. What we did last Thursday was by substitution. We did problems like number 3 on the warm-ups, where we plug in 3x minus 4 in for y. And the other type of problem we did was when they were both solved for y, both equations were solved for y. And remember what we did? We put them next to each other. Okay. So the first week we solved systems by graphing. So on a graph, we could see where the two lines either intersected, or we had parallel lines, which means they never intersected. There's no solution. And then occasionally we'll see that we'll have two lines that coincide. They lay on top of each other. We haven't graphed one of those, but so that was the first day of this unit by graphing. The second day was by substitution, either this way or both of them were solved for x, or excuse me, y, and we set them equal to each other. And then this week, today and Thursday, we're going to solve by a method called elimination. Okay, elimination. And when you get used to doing this way, elimination is going to be probably the one that you prefer the most. It's the one that I prefer the most for sure. Unless I have a graph and I can graph them. All right, so that's what we've been doing. We have been graphing. We've been solving by graphing and substitution. It says elimination is easiest when both equations are in standard form. What's the difference in standard form and slope-intercept form? You remember standard form versus slope-intercept form. Well, if we go back to the warm-ups, this one is in slope-intercept form. The top equation is in slope-intercept form. Slope-intercept form, slope-intercept form. And the second one is in standard form, when the x and y are on the same side of the equal sign. Okay, so one of your assignments this week is I give you a bunch of different systems of equations, and you have to say which method you would use to solve them, and you have to justify your answer. So if I was you, I would write this down. I would write this down. It's easier to use elimination when both equations are in standard form. I would write this down if I were you, because you're going to have an assignment. We're going to have to pick a method and justify your answer. So I would write down elimination is easiest when both equations are in standard form. All right, the method of graphing is best when they're both in slope-intercept form. Oh my goodness, can you read my handwriting? It's horrendous. I would use graphing when both equations are in slope-intercept form. And of course, you have a graph. This says both are in slope-intercept form. Both equations are in slope-intercept form. And I would use substitution. Tell me if I'm going too fast. I would use substitution when I have one of each, maybe. So one equation is in standard form. And one equation is in slope-intercept form. Like number 3 on our warm-ups. This is when we had one in slope-intercept form and one in standard form. And we use substitution, okay? All right, does anyone need another minute? And like I said, this is being recorded. If you want me to send you the recording when we're done, I will be happy to. All right, so we are going to get started with elimination. Like I said, when you get used to doing elimination, it's probably the easiest of the three methods. All right, elimination uses opposites to get rid of variables. Okay, and I'm going to show you exactly what that means. All right, here we go. Everybody ready? Okay, just for a review. Oh, I'm going backwards. 5 is the opposite of -5. Does that make sense to you? Good. -10 is the opposite of +10. That's true. What is the opposite of 3? What is the opposite of 3? Yep, you got it. -3. What is the opposite of 4x? What's the opposite of 4x? -4x. That's exactly right. And what is the opposite of -5x? The opposite of -5x is +5x. So if you recognize opposites, then you're going to do well with elimination. Very good. Here we go. So we have two equations lined up. They're both in standard form, right? And what we're going to do is we're going to make this a big addition problem. So when I do this and I try to combine my like terms, see what happens to my x's? I have an opposite pair. Do you notice that? I have a positive x combined with a negative x. What's x minus x? What's x minus x? 0, just like 5 minus 5 is 0, right? So because these x's are opposite pairs, my x's are eliminated. Now I'm going to combine my y's. I have 1y plus 3y. What's 1y plus 3y? Very good, Miss Gama. It's 4y. And then what's 6 minus 2? 6 minus 2 is 4. Now, isn't this a simple little equation for us to solve? How do I get rid of times 4? I divide by 4, and y is equal to 1. Look at that. We're already halfway done. We've already solved for one of our variables. Y is 1. So remember, your answer has to be an ordered pair, and I already know my y value. Now to get my x value, I go back to one of my original equations and I substitute. Whoops, what did I just have? What was my answer? 1, right? Okay, thank you. Oh, I have very short-term memory. All right, so to get my x value, I'm going to plug in 1 wherever I find the simplest problem. And right here, this is pretty simple. Y is 1, so I'm going to put x plus 1 equals 6. To solve for x, I subtract 1 from both sides, and x is equal to 5. So my solution is 5, 1. And guess what? I'm done. Isn't that easier than substitution? Yeah, we like it. I knew you would. I knew you would. All right, did everybody understand what I just did? I hope you guys printed these problems. I hope you did. I hope you have plenty of examples for us to do together. All right, moving on. All right, so look at number 1 and 2. What you're looking for are opposite pairs. Do you see an opposite pair on number 1? Yep, I do too. 2x and -2x is an opposite pair. So I'm going to go ahead and say, all right, I'm going to combine everything. 2x minus 2x is 0. So my x's are gone. I'm going to combine -3y with -4y. What's -3 minus 4? -3 minus 4 is -7, right? And what's 4 combined with -4? What's 4 minus 4? 4 minus 4 is 0. Good. Now I want to solve for y. What's the opposite of times -7? I'm going to divide by -7. Those go away, and I'm left with, is this a real math problem? Can I put in my calculator 0 divided by -7, and do I get a real answer? We'll try it. If you're not sure, try it. Everybody type in your calculator, 0 divided by, I mean, it could be anything. 0 divided by 7. What does your calculator say? Does it give you a real answer? It does. The answer is 0. You are allowed to divide 0 by a number. Now, if your denominator is 0, your calculator will tell you made an error. If you divide 7 by 0, it'll say error, right? So this is a real answer. So y being 0 is a real answer. So that's my y value. I need my x value. So I'm going to go back up here to one of my original equations, and I'm going to plug in 0 for y. So I'm going to go ahead and use the first one. I know that 3 times 0 is 0, right? So 2y is equal to 4. Uh-oh, I'm sorry, it's 2x. What's the value of x, guys? If 2x is equal to 4, that means x is equal to 2. Oh my gosh, why am I writing y's? Yep, and that is my solution, 2, 0. Are y'all writing this down? Is everyone taking notes and working out these problems with me? I hope you are. All right, let's look at the next problem. Everybody good? All right, on the next problem, do you see a 0 pair or opposite pairs? Yep, we sure do. We see our x's are going to cancel again. So we're going to use elimination. We're going to use elimination because our x's cancel. So let me just box these in and mark them off. All right, you guys try this one. Try to do it before I get it. All right, when I added my y's, I got 3y equals -3. And then when you guys divided by 3, everyone should have had y is equal to -1. How'd we do? Give me a thumbs up if you got it. Yay, yay, yay. Good. All right, and now we're going to solve for x. So our ordered pair, we know our y is -1. So our ordered pair, you're going to stick it somewhere. It doesn't matter, just whatever. Right here is fine. So x and then 2 times -1 is -2. And then if we add 2 to both sides, we find out that x is 6. And if you plugged -1 into the second equation, you're still going to get 6. It doesn't matter which original equation you use. It doesn't matter. So our final answer is 6, -1. All right, I'm moving on. I'm moving on. All right, so I don't know why all of these, well, okay, so these are special situations. So hopefully you guys have these problems already written down or you printed them. I hope you did. All right, so look at number 3. Do you see an opposite pair or opposite? Yeah, opposite pair. You see opposite pair? All right, so let's see what happens. My pen keeps going off. So what's 3x minus 3x? 0. And now look at our y's as well. What's -2y plus 2y? Well, it's also 0. Do you agree with me? So all we have left on the left side of the equal sign is 0, but everything cancels. And then on the right side of the equal sign, what's 17 minus 16? 1. So look, guys, we don't have any variables, and all we have is the statement 0 is equal to 1. Is that true? Is 0 equal to 1? No, that's not true. So when you get a statement like this that is not true, that means there is no solution. And ultimately, what would that mean on a graph? If I have 2 lines that never intersect, what will I have? I have two parallel lines, right? Because parallel lines never intersect. So if I graphed these two lines, I would find out that I have two parallel lines. All right, now let's look at number 4. So I know at least my x's are opposite pairs. So I am going to use my elimination method. So I see that negative 4x plus 4x is 0. Those are gone. I also notice my y's cancel, don't they? Y minus y is also 0. So what do I have on the left side of the equal sign? 0. And now on the right equal sign, or the right of the equal sign, I see negative 10 plus 10. Guys, what's negative 10 plus 10? Yeah, it's 0. All right, now look at my statement. My variables are gone and my statement is 0 is equal to 0. Is that true? Yep, that is true. So if you have a true statement and all of your variables are gone, that means you have an infinite number of solutions. Infinite number of solutions. So basically, if I graphed these two lines, they would coincide. They would be right on top of each other. It's the same line, they're just written differently. So every single point for both lines are solutions to this system. All right, how are we doing out there? Everybody good so far? Okay, good. All right, so I have two problems. I want you guys to try these. Now, the other problems we did, it seems like the y's always, I mean, the x's always canceled, but on these two, hopefully you'll notice that the y's will cancel. So I want everybody to try these two problems, and I want you to send me your solutions on chat. I'll give you just a few minutes. Everybody give it a try, please. All of you, 100% of you, give it a try. Yes, Ireland, on the last problem when we had 0 equals 0, the answer was infinite number of solutions. Everybody should be trying these. Some of you are just sitting there not doing anything. Ashlyn, your first number is correct. The second one is not correct. Both of these have a solution. Everybody get busy. Give it a try. No, IF. Those are not right. Sorry. No, Ashlyn. Go to the second one. Try the second one if you missed the first one. All right, I know most of you aren't finished. I'm so sorry we're running out of time and I got to get on to another one more skill, okay? All right, so make sure you're doing this with me. So on the first one, hopefully you notice the y's cancel. So these are gone. So we have our x's, 3x plus 2x is 5x. Our y's canceled, we have 15, right? And then we solve for x by dividing both sides by 5. So our value of x is 3. How'd we do? I subtracted instead of added. Got it. All right, so now to get our y value, we're going to plug in 3 somewhere. I'm going to do it the second one. That's just how I roll. I like to look for positive signs and little numbers. That's what I look for. All right, so 2 times 3 is 6. 6 plus y is 8, right? And then to solve for y, we would subtract 6 from both sides and y equals 2. So our answer is 3, 2. And the way you can check, okay, so I'm about to give you a really big hint right now. Are y'all listening to me? When you do one of these problems on the milestone, you're not going to have to write it out. You're going to have multiple choices. Okay. This is a great testing strategy if you're listening to me. You're going to have choices like letter A is going to say 0, 6. Letter B is going to say 3, 0. Letter C is going to say 3, 2, so on and so forth, okay? Do you need to take the time to solve all of these? No, you don't. This is what you do. You take these numbers, you plug them in and see which one gives you 2 correct answers. If x is 0, 3 times 0 is 0. And does 0 minus 6 equal 7? No, guess what I'm going to do? Gone. I mean, it's faster if you can use elimination and just do it. If not, if you have no idea what you're doing, plug the numbers in. Okay. Then letter B says the answer is 3 and 0. Plug in 3 times 3 is 9. Does 9 minus 0 equal 7? Nope. I'm done with that one. Let's go to letter C. If x is 3, does 3 times 3 is 9. Does 9 minus 2 equal 7? Oh, this might be the right answer. Let's check the second one. Plug in 3. 2 times 3 is 6. Does 6 plus 2 equal 8? Yes. And I know my answer absolutely without a doubt is 3, 2. Okay, so that's how you can check your own answer when you solve these. But if you're doing a multiple choice question, a test, you don't know how to solve these, you forget, you know what you can do? Plug them in to get X and Y. Okay, make sense? But right now we're going to continue practicing on actually solving them in. All right, so someone just asked me, how did I get the X coordinate? Well, we solved for Y first, right? We solved for Y. We said Y is 2. So I have two choices. I can plug in 2 right here to get my X value, or 2 here. I chose the second one. And I said 2 times, or 2x, excuse me, plus 2, because 2 is Y, equals 8. And then I solved for X by subtracting 2 from both sides. And then I divided by 2, and I got X equals 3. So once you solve for one variable, to get the second variable, you plug in to one of the equations. All right, let's do, oh, we did the opposite. Maybe I solved for X first, and then we plugged in X to get Y. I don't remember. I think we solved for X first. You just did the opposite, okay? All right, let's look at this problem. So hopefully you guys realize our Y's canceled. So we had 2x plus 1x is 3x. Our Y's are gone. 18 plus 12 is 30. And now we're going to get rid of times 3 by dividing by 3. So X is 10, right? Now how do I solve for Y? I take my answer, X is 10. I can either plug in 10 here for X or here for X. It does not matter. I'm going to plug it into the second one. If X is 10, I'm going to write 10 minus 3Y equals 18. I'm going to subtract 10 from both sides. I get negative 3Y equals 8. And then when I divide by negative 3, I get Y is equal to negative 8/3. I don't care if it's a fraction, I'm done. So my answer is 10 and Y is 8/3, negative 8/3. How do we feel about that? Okay. I know this is I know it's a hard unit. It's the last one. We've built up to this all year. All right, now let's look at the next scenario. Sometimes you don't have a pair of opposites. Look at this. Are our X's opposite of each other? No. Our Y's are not opposites. So what are we going to do? We have two other choices. We can either solve them both for Y and find a graph and hope our answers are whole numbers. We could use substitution, which takes a lot of work, or we're going to create an opposite pair. We're going to create an opposite pair. Hold on. Don't steal my thunder. All right, so my X's have the same coefficient of +1. What's the only thing that will cancel out a +1? A -1. So I want one of these X's to equal -1x. What can I do to X? What can I multiply X by to make it equal -x? The only thing I can multiply X by to make it equal -x is -1. Do you agree with me? So I am going to force one of my equations to have an opposite pair. So I'm going to take either equation, it doesn't matter, either equation, I'm going to take the top one and I'm going to multiply the entire equation by -1. Okay, so I'm going to distribute that -1. So I'm going to write -1x minus 2y, and -1 times 0 is 0. There's no such thing as -0. It doesn't exist. All right, so I rewrote the top equation, and now underneath it, I'm writing my second equation. And now I have forced us to have a negative pair. Thanks, Evan. Okay, and all I did was create a negative pair by multiplying a whole equation by -1. So now I notice that I have a pair of opposites, so my X's cancel. What's -2y plus 1y? That would be -1y is equal to 2. And when I divide both sides by -1, I get y is equal to -1. Whoops, -1. So my y value is -1. And now to solve for x, I can use any of these equations. I can use this equation, I can use this equation, or I can use my original equation. It doesn't matter. I'm going to plug into this one. It's the most simple problem I see. So if if y is -1, here's my math problem. I'm going to add 1 to both sides, and I see that x is equal to 3. And that is my solution. Okay. Now on your notes, I had already typed all this out for you. There it is. Okay. So if you go back and go, I forgot how we did that. Well, I've typed out what we did, all we did on our notes. I made the second one. I multiplied the whole second equation by -1. On the one I just did with you, we multiplied the whole top equation by -1. All right, we're going to do these 2 problems, and then we're going to go at 3 o'clock on the dot. If you drop out, that's okay, but I'd rather you stick around for 2 more problems. All right, so on 18 and 17, we're looking for opposite pairs. Since there aren't any, we're going to force us to have one. So then what I'm looking for is at least the same coefficient. Well, my 9s are the same here, and on 18, my 2s are the same, right? My y's are the same. So I know the opposite of 9x is -9x. The only way to make one of these equal -9x is to multiply the equation by -1. It doesn't matter which one I do it to, okay? Doesn't matter. I'm going to do the second one just because I chose it. I'm going to rewrite 9x plus y equals 25. The first one, just like I see it. The second equation, I'm distributing the -1 to every single term, not just one, but every single term. I have an opposite pair. So 1y minus 5y is -4y. 25 minus 17 is 8. And now I'm going to divide both sides by -4. So y is -2. Then I'm going to plug in -2 for y. So I have 9x minus 2 equals 25. And there's the answer. I'm rushing through because I know our time is up, but I want to do number 18. All right, I see that I do not have a opposite pair, but I do have the same coefficient. So I want to make one of them negative, which means I'm going to multiply one of my equations by -1 so I can have an opposite pair. So I'm going to just choose the second one just because. Everybody do this with me. Awesome, Kylie, that's good news. All right, so on the bottom one, we're distributing that -1. We got -7x plus 2y equals +13. A split, yeah, for a little while. All right, so 8x minus 7x is 1x. Our y's are gone. And then we have -1. X is -1. And then to get my y value, I'm plugging in -1 for any of the x's. So I'm just going to do it to this one right here. So -1 times 7 is -7. I'm taking my original equation. So 7 times -1 is -7 minus 2y equals -13. I'm going to add 7. So I have negative 2y equals negative 6. And then when I divide by negative 2, I see that y is 3. So my solution is negative 1, 3. All right, guys. I know this is challenging. If we were in a classroom, we would be doing this 2 or 3 days. And I know that we're trying to get it done in 45 minutes. So I just encourage you guys to practice. If you need to Google how to solve systems by elimination, there's a lot of videos online that can give you some extra practice. I encourage you, if you want to do this well and you want to understand it, you have to practice. So a lot of times it's up to you when you're a virtual student, okay? All right, so when you guys are going through your assignments, let me know when you have questions. We'll finish up this lesson on Thursday, and then we'll take a break next week and finish the following week. All right, guys, thank you for your attention and cooperation. Everybody have a great day. Bye, guys. Have a good one. Bye. Bye, Eli.